Hello, so welcome to the final part of this chapter, and in this part we're going to be looking at power. Okay, so previously we've looked at work. So again, work is force times distance, and what that essentially means is when, let's say, we're pushing an object, so let's say we're pushing a box forward. Work basically tells us how much energy we're transferring, how much energy we're putting onto the object to move it forward. Okay, but actually, what we kind of worked with, no pun intended, is that it was a fixed number, right? When we worked out the work done, it was always just a number. So it's just a fixed constant number. But in reality, work will change, right? Like, it will change over time. So if you really think about it, let's again think back to pushing a box or even working out or doing something physical, right? Are you going to be doing you're going to be putting in the exact same work all throughout the time you're active? No, there's going to be a bit of times that you'll be achy, and there might be times where you have a bit more power and a bit more force. So it changes, it fluctuates, right? So the actual force we put onto an object, the work done to move it, is going to change. Anyway, so then that leads on to the idea of power, and actually power is, I write it here, power is the rate of work. Okay, so that tells us, in other words, more simply, so power tells us, I'll do it here, the work done, obviously to move an object, right? The work done per second. Okay, so it's this idea of how much work we're doing, but the rate, so how much we're doing per second. Okay, so a high power means we're doing a lot of work. A lot of work every second. Low power, less work. Okay, that's the idea. Okay, so then as a formula, then it turns out that power is the specifically the driving force. So remember, that's the force that acts forward to move an object forward. That's the driving force times the speed of the object. Okay. And so obviously we've got the unit. Well, the driving force is in newtons, as is the force. Speed is in meters per second. So you could have the units as newtons per meters per second, but actually what you'd be more familiar with is that power can actually be watts. Okay, quite interestingly. Again, if you do some clever work, if you look at other formulas, combine stuff, eventually you can deduce this, but I won't. I'll leave it there for now. I'm not a physician, so it turns out power is in watts. Okay, and so I'll highlight it here. Okay, or more succinctly, we can just say that power P is dV. Okay, but obviously P is power, D is my driving force, and V is speed. Okay. And all we'll be doing it, we'll just be implementing this formula in this section. So we're going to just look at a bunch of questions now. Okay. So here are okay. So I got this question first. I'm told a car is traveling at 15 meters per second, and its engine is producing a driving force of 1,000 newtons. Calculate the power developed. So it's asking for the power effectively. So we know that the power, again, power is the driving force times speed, which again, as I recall, we literally just went over it a second ago here. So just simply using the formula, just simple use of the formula. So the power of my driving force, I'm told, is 1,000, and my speed is 15. Very simply, multiply them to get the power of 15,000 watts. Okay, and so there we are. Okay, so now we've got this question, and I'm told the engine of a van is working at 5 kilowatts, and the van is traveling at 18 meters per second by the magnitude of the driving force. So essentially, wants the driving force. Okay, so again, it's talking. It's not explicitly mentioned power here. However, um, it says the engine of the van is working at 5 kilowatts. That's actually kind of very subtly hinting at the rate of the work done. Okay, so the engine is obviously pushing the van forward, right? The driving force. So the engine's pushing the van forward. The engine is working, so it's the rate. So that means the power is 5 kilowatts. Okay. Pay very special attention. Some that they like doing that sometimes. They don't explicitly mention power. Um, working very specifically means power. Okay, because remember, power is the rate of work. Okay, so the power is 5 kilowatts, but it has to be in watts. That's going to cause an issue. It's in kilowatts. So remember again, a kilo is 1,000, so we need to multiply by 1,000, which is going to be 5,000 watts. Okay, and so at that point again, power, I'm going to say P is D times V. So power is driving force times speed. So that means 5,000 is going to be D times the speed. Now the speed is 18. Okay. Therefore, just divide by 18 to get the driving force to be 277.78 newtons. And there we are. Okay. Yeah, so now I'm told a van of mass 1,250 kilograms is travelling along a road. The van's engine is working at 24 kilowatts. The constant resistance to motion is 600. Calculate the acceleration of the van and the maximum speed. So it's kind of similar, um, but it's still a bit different to the last example. But let's have a let's try and figure out what's going on. So again, immediately I can spot this. The power is 24 kilowatt, and again we need to convert that to watts. So that's 24,000 watts times by 1,000, right? There we are. Okay, now if I draw the situation again, it's on a road. I got my van. I'm also told the mass now, which is 1,250 kilograms. I've got resistance, my resistance force, which again, if the van is going to be moving forwards, the resistance will act backwards like this, and that'll be 600. And then there would be a driving force because there's power involved. Power means there's a driving force moving it forward. I'll call that D. Okay, and there's also going to be some speed and acceleration. So firstly, speed. I'm told the speed is 6. Okay. Now the acceleration is what they want me to work out. It's asking me to work out the acceleration at this speed. I'll call that A. Okay. So I need to figure out the acceleration. Okay, but there's quite a bit of stuff going on here. Okay. Right, so hopefully with me here, I think this is the hard part, right? Once you've got your diagram, you've got all the information, it's just formulas at this point. Hopefully you're with me up to here. Right, so again, I'm going to look at my power equation, so I know what power is. So power P is driving force times speed, but I know my speed, it's 6, right? Okay, sorry, but I also know my power is 24,000, so I can add that on. So 24,000 equals 6 times D. And actually then I can find my driving force, right? Divide by 6, I get 4,000. So there we are. Okay. I can add that onto my diagram then, to make it easier to visualize what we have. So they want me to find the acceleration. So I'm gonna have to resolve, right? I'm gonna need to use F equals ma. So if I resolve again, forwards and backwards, left, right, and left. Well, my right force is my driving force, which we found before, 1000, take away my backwards force of 600, my left force. And so that will equal mass times acceleration. Again, F equals ma. So the mass is 1250 times a. So lots of a. Well, actually, then, if I just simplify this equation, that would be 3,400 equals 1250a. Then I can just divide by 1250 to get a. And I get 2.72. And there we are, meters per second squared. Okay, and so now in part B, it's asking us to find the maximum speed of the van. Okay, so if I sort of draw this sort of new thing, this new case that's going on, this new situation here. So I've got my van. Again, it will have the same mass, 1250 kilograms. The resistance force is still going to be 600 because it's constant, which means it will always remain the same. So it'll be 600 again. So that'll go back 600. The power of the van is still 24 kilowatts. The power remains the same as well. So 24 kilowatts. Well, that's 24,000 watts. So that's my power. Okay. And so again, there will be a driving force again acting forwards because power exists. However, in this case, not the power, the driving force is going to be different. So I'm going to say D dash, okay, to signify it's a different D. Okay, so it's a different force to in part A. Because the driving force now may change because the speed is going to change, okay? So the speed changes, it's likely the driving force will also change with it, okay? Because in part B, the speed is different. It wants me to find the maximum speed now. And so the maximum speed, again, that's when the acceleration is 0. Okay, so I'll say the acceleration is now 0 because it's at maximum speed. That's what it means. Again, the speed is v. This v. I want to find v. Okay, so that's the situation here. Okay, so again we've got power. Again, we know that power is driving force times speed, so it's going to be d dash, which is my driving force here, times my speed v. Okay. Well, my power is of course 24,000, so that's going to equal d dash v. Okay. Right. Um, so if I want to find v, I'm going to need to find my driving force. Okay. How can I do that? Well, if I now resolve, because I know my acceleration, forwards and backwards. Well, my forwards force is my driving force d dash. Take away the 600 newtons acting to the left. That's going to equal mass times acceleration. So 1250 times the acceleration. Well, the acceleration is 0. So actually, this again equals 0. So that just means my driving force is now 600. And you can see it is different because my driving force in part A was 4,000 newtons, but now it's gone down to 600. So it may change, okay? So there we are. But now I know my driving force, so then I can use this, my power, to say that, well, 600 times V is going to equal 24,000, which therefore means my speed V is going to be 40, okay? So that is my maximum speed, okay? Cool.